For my PC support standard, I've 3D modeled most everything in this standard. I've imported most of the 3D models that I can into a game called Tabletop Simulator, where I will be explaining the parts. I'll be explaining the other parts using different methods. Once I am done with the standard, I will open source all of my 3D models. Let's get started. The first benchmark is all about data storage, and the floppy disk was one of the first methods of data storage. They come in three different form factors: an 8-inch, a 5.25-inch, and a 3.5-inch, which is what this floppy disk is. Floppy disks, however, quickly became obsolete due to new methods such as flash drives, because they can only store mere megabytes. Next up, we have HDDs and SSDs, which, as you can see, I have two models here representing each of both parties. One thing you should know about both of them is they both come in two different options: external and internal. External will allow you to take that device or storage solution and plug it into multiple computers easily and transfer files, or if it's internal, it can be used as the primary storage solution for a computer. Now let's take a closer look at hard drives. Let me just switch over. Just give me a second. Okay, this is my brother. Well, this is a model of my brother's 2 terabyte Western Digital external HDD. The thing about HDDs, they come in two form factors: a 3.5-inch for desktops and a 2.5-inch for laptops. Now let's take a look at the inner workings of an HDD. As you can see here, we have the platter, which is the magnetic disk that the data is actually stored on. It rests upon a spindle, which is spun by a motor. Then we have the arm, which writes to the disk. Typically you have one arm for every platter you have. Now here you have the head, and there's the actuator. The head is the part that actually reads and writes to the disk, and the actuator is what pivots the arm. Next up, we have the two main methods of an SSD. First off, you should know that SSD stands for solid state drive, and it has no moving parts, and it's based upon flash memory. The two main versions of SSD storage are NOR and NAND. NOR, how it's structured is the data is stored in parallel to the bit line. This allows the data to be retrieved quickly, and also does not need to be loaded onto the RAM before the code is executed, which is a plus. Then we have NAND, which how NAND is structured. It is structured in a series, so in order to retrieve the data, it has to go through all of the nodes before it reaches the data, then it transfers back. This causes the need for the data to be loaded onto the RAM. The thing about NOR is typically used in BIOS because it is expensive, and also it is expected to be error-free, whereas NAND isn't. So NAND is typically used in solid-state drives. One last thing about HDDs and SSDs is SSDs do have better performance than HDDs, but HDDs are just simply cheaper and easier to make, thus they're more popular. But with the advancement of technology, the gap in the price may drop. If not, SSDs may become cheaper than HDDs. That is all I have for HDDs and SSDs. Thank you for watching. Next up, we have optical drives. The two main discs that go into an optical drive are a CD and a DVD. CD stands for compact disc, and DVD stands for digital video disc. CDs are typically used to store data such as a program you may have bought, and a DVD is typically used to store a movie that you may have rented from Blockbusters. The first kind of CD that came out was a CD-DA, and it was only made to store and play sound. Following that, many other kinds of CDs were made, such as a CD-ROM, which stands for read-only memory, a CD-R, which can only be written to once, and a CD-RW, which can be rewritten to as many times as you want. Also, there are DVD versions of the previous three I just mentioned. In addition to that, other kinds of CDs include the Video Compact Disc, the Super Video Compact Disc, Photo CD, Picture CD, CD-I, and many others. DVDs and CDs share a common form factor. The standard is 12 centimeters, then there is the mini, which is 8 centimeters. One thing about DVDs is that they can store more data in it compared to a CD. The reason for this being is that they can have more layers of the material that stores the data, which we will cover right now, and let us discuss the 4 layers of a CD. First, let us assume that each 4 of these CDs represents an individual layer of a CD. First, we have the sticker. The sticker usually displays something about the CD. Here is an example right here. As you can see, it says what kind of CD it is, and also who manufactured it, which is right over here. And also the sticker is green, which is the artwork. Now back to my little diagram over here. The next is just a protective layer for the layer that is directly underneath it. This is a shiny layer. If you ever looked at the back of a CD and observed that the back of the CD was shiny, that is because of this layer. When a computer reads a CD, it shoots a laser at it, and that's what it bounces off of. The bottom layer is where the data is actually stored. If you ever scratch the bottom of your CD and the data on it is corrupted, that is because you actually altered the data. Now, the reason why DVDs can store more data than a CD is because on this layer, it can store multiple layers of it, thus increasing the total storage. When a computer reads a CD, it shoots a laser through the bottom layer, bounces off of that layer, and comes back to the computer so the computer can read it. And the difference in the light is how a computer tells what data is on the CD. And that is all I have for optical drawers. Thank you for watching. Now we are on to SD cards. SD stands for Secure Digital. There are 4 families of SD cards. The first is SDSC, which stands for Secure Digital Standard Capacity. It was designed to be an improvement to the multimedia card, and there's nothing really special about it except for the fact that it was the original card. Next, we have the Secure Digital High Capacity Card, or SDHC. It was released in 2006, and it could store up to 32 gigabytes. In addition to that, the version 2.0 of the SDHC includes interface speeds of 25 megabytes a second. In addition to that, it was the first SD card to include the UHS, which stands for Ultra High Speed Bus. Following that, we have the SDXC, which is the Secure Digital Extended. It was announced in January 2009, and it supports up to 2 data, and some renovations were made, such as the version 3 of the SDHC and the SDXC. Interface speeds of 50 to 104 megabytes a second, and it achieves the speed using the new UHS. In addition to that, the version 4 of the SDXC supports interface speeds of 156 megabytes a second to 312. However, it does require an extra row of pins for the bus. And last, we have the Secure Digital Input-Output card, which is designed for things such as modems, GPSs, and FM radios that have a special kind of input and output that require a different card and software in order to properly use the input and output stream this device provides. One last thing about SD cards. SD cards have three form factors. The standard is 32mm by 24mm. The next one down, which is the mini SD card, is 21.5mm by 20mm, and the smallest SD card is only 11mm by 15mm. And that is all I have for SD cards, but however, I do have a small animation of my SD card 3D model, but since the text is in the second dimension, it cannot show the text in the animation. My apologies for that. And here is the animation right now. The last storage method solution that you actually physically interact with that we will be discussing today is the USB flash drive. This flash drive was modeled after one of the Cyber Patriot flash drives that I received last competition season. The USB flash drive was invented by an Israeli company called M Systems. However, their design was a bit different from what it looks like today. The first generation of flash drives that were commercially available came from IBM, and it contained 8MB of storage. And with the advancement of technology, those 8MB quickly increased all the way up to a terabyte in 2013, and still is increasing. The second generation of flash drives had read speeds of 30MB a second and write speeds of 50MB a second, which were a lot faster than other USB devices at the time. Then with the advancement of USB 3.0, the third generation of flash drives came out. These flash drives had interface speeds of 5GB a second and were also backwards compatible with USB 2.0 ports, because USB 2.0 ports are still fairly common. And that is all I have about USB flash drives, and I also do have another animation for this 3D model that I made. The final data storage solution I will be discussing today is cloud storage, as you can tell from my little red cloud right there. Cloud storage is when you store data on a server or service somewhere else, and you can supposedly retrieve that data anytime, anywhere, as long as you have an internet connection and something doesn't go wrong with the servers. In my opinion, cloud storage is great if you want to store something like pictures or text documents, but however, if you need to store something secure like your work, I wouldn't recommend it, because cloud data storage centers are typically a target for cyber attacks, and if their cyber defense team isn't that good, well, you're out of luck. Some cloud examples include G Drive, Git, and Dropbox. Well, that is all I have for this benchmark. I hope you enjoyed it, which I doubt you did because this is just one giant lecture, but that's what my standard is. Thanks for watching. Bye.